We're going to use a kitchen sink faucet to demonstrate the difference between turbulent flow and laminar flow. First, laminar flow. I'll turn the faucet on, and if you notice the stream of water coming out, it's a very clear stream. In fact, if I put my finger behind the stream of water, you can clearly see the image of my finger through the water. This is laminar flow, where the water molecules are basically traveling in parallel with each other, and not in a turbulent or mixing fashion. However, if I turn the water flow rate up, the flow stream becomes turbulent. You'll notice if I put my finger behind the water stream now, you see the image fluctuating. This is the turbulence of the water molecules passing by. Turning the water flow up even more, we see the stream begins to blur the image of my finger. I'll have to turn it down here so I don't overfill the picture. Now we're back to laminar flow. Laminar flow, once again, you see my image of the finger clearly through the water stream. The water molecules are moving parallel to each other, and they're not obscuring the vision whatsoever. There's another indication of turbulence in a water flow stream, though this is more indicative of what's happening in the valve of the faucet than the stream itself, and that is the sound it produces. Listen very closely, and you can hear the onset of turbulence as a hissing sound in the valve. What you hear there, that hissing sound, is the turbulence of the water making its way through the valve. If I turn the flow rate down, the hissing goes away. That's indicative of laminar flow through the valve, where once again the water molecules are moving in parallel fashion to each other. They're not moving back and forth turbulently, and therefore not producing that hissing noise. Now, turbulence begins to manifest itself inside the valve before it does in the liquid stream. Reason being is the diameter of the passageway in the valve is much smaller than the diameter of the nozzle here. The velocity is therefore higher inside the valve than it is at the nozzle, and as a consequence, we see turbulence exhibit itself in the valve before we see it in the stream. So you may have seen before in the video, where as I turn the water flow up, you begin to hear a bit of a hissing sound in the valve before you notice turbulence manifests itself visually in the stream. But that's an example of laminar and turbulent flow in the water stream coming from a kitchen sink faucet.